Hello, Assalamu alaikum. How are you, dear students? Hope you all will be fine. Today we are going to discuss an important topic about the concepts of acid and bases. As we have discussed before this Arrhenius concept of acid and bases, and we saw many defects in Arrhenius concept. And the main defects that were observed in our Arrhenius concept were number one, that to prove as an acid or a base, there the medium required is an aqueous medium. That means that aqueous medium is necessary for the conformation of Arrhenius acid and bases. And second defect that was observed in Arrhenius acid and base was that that concept is based is focused only for those substances which have hydrogen ions or hydroxide ions, and it exclude the concepts for those substances which do not have hydrogen ions or hydroxide ions. The next concept that was presented by Bronsted-Lowry in 1923, that was the more widely accepted concept about the acid and bases. This concept was, as I mentioned earlier, was presented in 1923, and two scientists, one was Bronsted, that was a Danish chemist, and Lowry, that was an English chemist. They presented this concept, and this concept was based on the proton donation acceptance. Those substances were said acids which can donate a proton, and those substances were bases which can accept a proton. It means that there was no need for the aqueous medium to prove these acid and bases, and this basis was also not limited for those substances which contain hydrogen ions and hydroxide ions. The main definition, dear students, Bronsted-Lowry concept is acids, a substance which can donate a proton. It means acid is the only substance which can donate a proton to another substance, and base is a substance which can accept a proton from another substance. It means to prove Lowry acid and base, there should be two compounds. One compound must act as an acid and the other compound must act as a base. The only acids cannot be proved according to this concept, that either acid or a base, and similarly base cannot be proved, a single base cannot be proved, that is either is a acid or a base. To prove acid and base, you have to mix two substances. One substance will act as an acid and other substance will act as a base. This was the main condition for the Bronsted-Lowry concept. Let's have an example to prove that this concept. Acid, for example, HCl is an acid here, and ammonia NH3 is a base. Acid has a proton H positive and it can donate to proton NH3. NH3 will act as a base and HCl will act as an acid. After accepting a proton from HCl, ammonia will change into a ammonium ion, and after giving hydrogen ions, HCl will change into a chloride ion. It is a reversible reaction, remember. Similarly, HCl when reacted with water, HCl gave its proton to water and water accepts that proton. Therefore, water here there is a base and HCl is an acid. After accepting the proton, water will change into a hydronium ion H3O positive, and HCl will change into a chloride ions. Remember there is one acid and other is a base. Only acid cannot be proved here, that is an acid, and only base cannot be proved here, that it is a base. They should react and act together at the same time, then it will be proved that they are acid or bases, dear students. Now the next concept was what are conjugate acid and what are conjugate base. To understand this concept, dear student, let's have an example. Example is ICl reacts with water to form, as I mentioned earlier, to form hydronium ion and a chloride ion. As it is clear from this equation, that is a reversible reaction, and reversible reaction contain two reaction. One is a forward reaction and other is a reverse reaction. In a forward reaction, what happens? ICl react with the water to form hydronium ion H3O positive and a chloride ion Cl negative. This is a forward reaction. Here ICl will act as an acid and water will act as a base. Now it's a reverse reaction. Reverse reaction is hydronium ion H3O positive plus chloride ions react together and they form HCl and H2O. Here what happens? H3O positive give a proton to Cl negative, and therefore it is it will act as an acid, and this acid will be known as a conjugate acid. Conjugate acid. And chloride ions accept a proton from water, therefore it will be known as a conjugate base. Now the H3O positive is a conjugate acid and Cl negative is a conjugate base, and after accepting Cl negative, accepting a proton, it will become HCl, and after giving a proton, H3O positive will change into H2O. This is the reverse reaction of the above reaction. Keep in mind, dear students. Now we can say that HCl and water react to form hydronium ion and a chloride ions. Here HCl is an acid and H2O is a base. In a reverse reaction, H3O positive will act as a conjugate acid and Cl negative will act as a conjugate base. Now see this, that ICl gives a proton to hydronium ion, and hydronium ion is a base, and when it accepts a proton from an acid, water becomes a conjugate acid. Remember, HCl as an acid, when it gives a proton to H2O, H2O change into a conjugate acid. It means conjugate acid is formed when a base accepts a proton from an acid. And now the conjugate base is Cl negative. How it is formed? It is formed when H positive is given to water. When acid gives H positive ions to a base, it changes into a conjugate base. Now we can define conjugate acid and conjugate base, dear student. A species formed by the acceptance of a proton by a base, means when a base will accept a proton, it will change into a conjugate. A species formed by donation a proton by an acid, means when acid will give a proton to a base, acid will change into a conjugate base. The examples of conjugate base are chloride, as I mentioned here, and other examples are ammonium ions and hydronium ions, as hydronium ions is present here. You can see in this equation. This is a basic concept, dear student, often asks about the conjugate acid and conjugate bases. Now the next question that is often asked, that is what are amphoteric species? Amphoteric species, students, are those species which can act as an acid as well as a base. These species, when they act with acid, these species will act as a base, and when these species act with a base, then they will act as an acid. Means they have the both properties of acid and base, and those species are usually known as amphoteric species. Definition. What is definition? We can define amphoteric species as a substance which can act as an acid as well as a base, mean it has both the quality of acid and a base. Like water H2O, when react with HCl here is an acid. Now water will act as a base to form hydronium and chloride ions. Now if water is reacted with H2O is reacted with NH3, that is a base. Now the water will act as an acid. Here it will act as an acid, whereas here it has acted as a base. Water will act with ammonia to form ammonium ion and hydroxide ions. Here water is an acid, and in this equation it was a base. It is concluded from this discussion that a species can act as an acid as well as a base depending on the nature of the other substance. If the other substance is acid, that amphoteric species will act as a base, and if the other substance is a base, that amphoteric species will act as an acid. The next question that is usually asked, that is about the neutralization reaction according to Bronsted-Lowry concept. Neutralization reaction is that reaction in which acid and base react together and form a substance. In Arrhenius concept, acid and bases usually react to form water and salt, and that is called a neutralization reaction. Whereas in a Bronsted-Lowry concept, acid and bases react to form conjugate acid and conjugate bases, and this is known as a neutralization reaction according to Bronsted-Lowry concept. Acid and bases will react to form conjugate acid and a conjugate base. As far as the limitation of this concept are concerned, the limitation are very simple. This concept was only based for those substances which can donate a proton or which can accept a proton. There are many species which act as an acid. They do not either have a hydrogen ion or a proton like CO2, and there are many species which do not have OH ions, or they cannot accept a proton like calcium oxide, magnesium oxide, but they can act as a base. These are two limitations that was observed in a Bronsted-Lowry concept. The summary of this concept, dear student, very simple. Acid are those substances which can donate a proton, and bases are those substances which can accept a proton. After conjugate acid is a species which is formed by the acceptors of a proton by a base, whereas conjugate base is a species which is formed by the removal of a proton from an acid. Amphoteric species are those species which have the properties of both acid and bases, depending on the nature of substance. Other substance they react. If they react with the acid, amphoteric species will react as a base, and if they react with the base, amphoteric species will react as acid. This was the basic concept about the Bronsted and Lowry. Next video, inshallah, we are going to discuss the Lewis concept of acid and bases. Till then, keep remembering me and your prayers. Allah Hafiz.